So we're looking at page 4 of exam 3 for the spring 2018 exam. And here it's asking us to draw the reaction profile diagram for this reaction. It's asking just to basically label and make sure that we draw a complete diagram. So before we draw a reaction profile diagram, we have to know what the mechanism is. So if you're ever asked, let me just zoom in here. If you're ever asked to draw the reaction profile diagram, you need to know what the different steps are that you're taking. So draw your mechanism. And this is our hydrohalogenation, right? So we are making our alkene grab that hydrogen. You make a bond, you break a bond, right? Since this is a symmetric set of carbons in our alkenes there, we can put our plus on either one of them, right? There's no difference in the stability of the carbocation, either one of those on either one of the carbons that are involved in the alkene. There's no shifts, there's no rearrangements, so we are at the most stable carbocation. Once we are at the most stable carbocation, that's when we bring in our negative, right? So we will bring in our minus, our bromine there. Let me draw this in red. Negative attacks the positive. What is my computer doing? Negative attacks the positive. Okay. And we are left with red here, right? And there. Okay. And technically speaking, that is a chiral center, so we should, show a racemic mixture, but it's okay, right? We're not. That's not going to change our reaction profile diagram. Okay. So what do we do from here? Well, here's where we start, right? Here's where we end. Here's our reactants, and here's our products. So if we're not at our reactants and we're not in our products, anything, right, anything in between the reactants and the products, that's our intermediates. Okay, so if we're not at the beginning, we're not at the end, whatever's in between is our intermediate, right? Which kind of makes sense. That's why it's gotten the term there, okay? Now remember, when we're dealing with at least the first semester of organic chemistry, we don't run into too many intermediates. And what I mean with that is we typically only deal with carbocations or free radicals or maybe even some protonated alcohols. There's a very limited set of intermediates that we deal with. But if that doesn't quite make sense, then just think about anything in between the start and the end being an intermediate. Now, anywhere you see a red arrow, so red arrows, this is a transition state. Okay. Now, a transition state is where bonds are being broken or made, right? So another way of thinking this is a transition state is represented by our mechanism arrows, right? Anytime we're making bonds or breaking bonds, that's where a transition state occurs. Okay. So we need to kind of plot this all out, all right? So now that we have the mechanism, we've kind of labeled everything. Oops, I'm sorry, I missed one part of it right here, the slow step. The slow step is right here, okay? The slow step is the formation of the carbocation. That tends to be a very common slow step. So if you're kind of on the fence about what's going on, typically a formation of a carbocation is our slow step. And I think now yeah, okay, it looks like I answered all those questions up there. So now let's sketch this out. Okay, so we need to draw a simple XY coordinate. We have some measure of energy over here, and we have reaction coordinate down at the bottom. Now, typically, or I should say, technically speaking, we could measure different types of energy to put on our y-axis there, but it doesn't really matter. That's a little bit more in the realm of physical chemistry, or the second semester of general chemistry, where you talk about Gibbs free energy or enthalpy, entropy, these kind of things. So we'll just have a generic energy label there. Reaction coordinate on our x-axis just simply refers to how far along in the reaction are we. Right? So a reaction profile diagram is basically our Google Maps to get from the beginning to the end, right, of our reaction. And so we draw our reactant line over here, right? We start at a certain energy level and we end at a certain energy level. And your question might be, well, how do I know that the reactants and products are there? Well, we would have to calculate the energy, right? We'd have to calculate whatever energy that we're dealing with for the two trans 2-butene and the HBr, right? And then we could get a measure of that energy, and we would have to do that same measure for our products. So we are just arbitrarily picking here. These tend to be exothermic reactions, or these tend to release energy, I should say. So typically the products are below the reactants, although that's not always the case. Not too relevant for what we are dealing with, though. Okay. Right now we're just drawing a generic reaction profile diagram. Let's mark this in orange, right? So intermediates are the valleys. So between the reactants and products, we're going to climb some hills, and our intermediates are the valleys that we run into in between there. Okay. We only have one intermediate, so we only have one valley. That means what happens is our reactants have to climb a hill to get to that valley. They have to climb a second hill, and they will get down to our products there. Okay. There's a transition state, and there's a transition state. So the top of the hills are our transition states. Our intermediates, right, are the valleys. The slow step, what color did I use for slow step? Black, okay. The slow step is, another way of thinking about it, is represented by the highest hill to climb, right? So from the valley to the top of the hill, right? The higher the hill, the longer it's going to take to ride your bike up that hill. So it's going to be the slow step for the reaction there. So it's a relative thing, the relatively highest hill to climb, okay? You don't have to draw those lines in there. I'm just showing you guys what I mean by where the slow step. Let me get rid of that black mark there. I'm just showing you guys where that, oh no. I'm just showing you guys where that slow step comes in, okay? So this would be what we want to show for our answer for this, right? The equal sign with a slash through there, right? That's just our symbol for a transition state. So if you see something like this, right, that's just a transition state symbol. Our intermediates, we specifically showed it, we underlined it, we colored it. So this would be a perfectly acceptable answer for this. As you have more complex reaction mechanisms, you're going to have some more intermediates, and that means you're going to have some more hills to climb along the way. Okay, but this is pretty simple, pretty straightforward, and this is going to be extremely important when we start to talk about Chapter 9, where we deal with elimination and substitution reactions.